Good afternoon. My name is Don Kudo. I'm with the Ontario Public Works Association. I'm a board of directors member and also past president of OPWA. So I'd like to welcome you to our OPWA Connects webinar today. It's a really great session we have lined up for you today. I really like this idea. We've got the mix of academic research and real life applications for, and we're going to talk about, it's a project of the year, a former OPWA 2002 Project of the Year Award. So it's a great session that we're going to have today. So let's, let me just get to my slides here. So yes, we have Durham Region here today to talk about their increasing service life and pilot project using recycled materials. So numerous Ontario agencies have realized that poor quality binders something that need to be addressed in pavement. This presentation will discuss how pavement service lives in Durham Region, how they've been able to improve it. With today's proper designs, they've been able to improve their pavement service lives starting from 2014 to the current day. So the rehabilitation of the Newtonville Road in Durham Region using recycled glass in the road base and recycled mixed plastics and polyethylene, PET fibers in the asphalt surface was the first of its kind undertaken anywhere else in Canada or any other country. So this leading edge project was created out of the desire of Durham Region Council to invest in the circular economy by exploring and assessing options of incorporating alternative waste materials in road construction. Contract was tendered in the spring of 2022 and constructed the same year. So today's presentation is going to speak to the many challenges that were encountered in both phases, and they're going to discuss some of the ins and outs of how the contract was successfully completed on schedule and under budget. And as mentioned, this project was also the recipient of the 2022 OPWA Project of the Year Award for the transportation category. So once again, as a OPWA Board of Directors member, I'd like to just talk about OPWA. There's many ways for you can get involved with our association through membership, of course. We have a number of committees, such as the committee that I currently sit on with the Education Committee, who brings this webinar to you. We have a number of events that I'll be showcasing the next slide, where we offer a lot of networking opportunities for our association and the industry overall. Sponsorship, we always are very glad that we have a number of industry sponsors that help our association continue to help with the networking events that we have. And we encourage any of you that do not sponsor the OPWA to consider sponsoring us. Awards, which is actually being highlighted today, as this is an award-winning project through OPWA, and we have an awards luncheon. We do provide Project of the Year awards for a number of outstanding projects in education. Yeah, that's why we're here today with our OPWA Connects webinar. So upcoming events, we have a number of monthly webinars coming up. The next one is coming up very shortly, which is the Conservation Authority Permitting and Approval. We have folks from the Credit Valley Conservation Authority presenting on that. April 17th, one of our featured events for OPWA is the Technology Showcase. So we will be showcasing one of those technology participants that were previously presented at our Technology Showcase. In May, we have another Project of the Year presentation lined up. And in June, we have the Canadian Wildlife Federation, who will be providing a presentation on right-of-way pollinator habitat. National Public Works Week is the third week in May. That happens right across North America. For OPWA, we have an event scheduled actually the week after OPWA, National Public Works Week, I should say. That is our OPWA Awards Luncheon. A great event. We usually get over 200 participants to this luncheon, and it's held at Mississauga Grand. And coming just before we hit summer vacation timelines, we have the June 20th, our annual OPWA Golf Day at Flamborough Hills. So I hope folks can come out for that great day of golf and networking. So once again, there's many ways to join us, and please check out our website to find out more details about OPWA. Okay, so here's some, we'll call them rules of engagement for today's webinar. All your participant microphones have been muted and cameras will remain off. Questions, yeah, so questions will be addressed at the conclusion of the webinar. For the most part, if you use the Q&A box that's shown on the icon at the bottom edge of your screen, there may be the opportunity for our presenters to answer your questions during the presentation, so you may get a direct response back. And our presenters have asked also that if you were to, not only, I guess, your name will show up on there as asking a question, but also to note your affiliation, what company you're with or what municipality. That will help them better answer your questions. And yeah, the webinar, we're expecting the presenters to be approximately about 40 minutes long here, and following their presentation, we can go to the Q&A. So today's presenters from on this Durham Region project, it's great. Once again, I'm noting that we have two presenters. Simon Hesp is an engineering chemist and a licensed professional engineer. He's a professor of chemistry at Queen's University since 1991, and his research on the development of improved asphalt acceptance specification tests and criteria has won him several awards and recently culminated in the publication and implementation of several significantly enhanced standard test methods. And from Durham Region, we have Dan Wechter. He's a civil engineer, and he is currently the Acting Director of Transportation and Field Services at the Regional Municipality of Durham, as well as the Manager of Construction. And in his role, he administers an annual construction program exceeding $200 million and over 2,400 lane kilometers of regional road network. So thank you to Simon and Dan for presenting today. And I will now turn it over to Simon.
Thank you, Don. It's a pleasure to speak to you today. It's been a long ride. I've been at it for about 35 years, working on asphalt to get Ontario municipalities and other agencies better roads. Today, I will talk a little bit about a success story, Durham Region, doing everything right and reaping major benefits. I hope to spend about 20 minutes on this, and then Dan Wechter will take over. We start off a little bit lightly. Most of my career has been about testing asphalt binders and mixtures. This slide just shows you can test anything. You can publish anything. As an academic, I compete to get my publication and my work published. And basically, I have ideas about what to test and how to test it. A little over 100 years ago, people would actually chew their asphalt at the plant, and they would be able to determine how soft it would be and how hard it would be. Maybe this was an inspiration for 3 Korean researchers who published in 2021 an article on the use of discarded chewing gum as a performance-enhancing modifier for road pavement applications. If you believe it, I encourage you to contact them to see what they have done since. Another lighter side of the industry, this fellow here, a bit odd, he likes to publish his picture all over the internet, 3 different sites. You can see he likes to smell asphalt pavements. Not sure what turns him on. Maybe he works for Professor Finney at the bottom right, who is fairly well known in the academic world. And some of you, I know, have heard of her. In 2011, she published a paper on the use of swine manure as a sustainable modifier for asphalt binder. And the abstract reads that biobinder, i.e. pig shit, will improve petroleum asphalt binders' low temperature properties. And it reduces the cost quite dramatically. It sells for 13 cents a liter versus 53 cents a liter at the time. If you believe it, give her a call. I think it may be a risky bet. This is my kind of research. I'm still looking for funding from the vineyards in Chile. They actually looked at the inclusion of byproducts from the red wine industry for controlling asphalt aging. I used to drink quite a bit of good red wine to prevent my own aging, but at the age of 60, I'm sorry to say my doctor advises against that, and I've stopped drinking too much. But on the odd occasion, I have a good glass. Again, I just want to show that anything can be published. Whether it's published or not doesn't mean it's true. Anyone can produce any kind of proposal on test methods for asphalt binders or mixtures. It doesn't mean you're going to get what you hope for, what you design for. So a little bit more seriously, we can look at pretty pictures of asphalt binder. On the left, an atom force microscopy image from 2011, a very well-funded group from the United States. They published these images, but about 10 years earlier, there was another group from Eastman Kodak that published very similar results. The top one, you see these zebra bags. They call them B structures or zebra patterns. And those are pretty much single crystals of wax. When the asphalt binder cools down, these waxes tend to crystallize on the surface, and they can contract a little bit because the base, what's underneath, is still hot. So they can contract and they form this wavy lay structure, which shows up like a B structure. And these are nearly perfect crystals of wax molecules in the asphalt binder. Now at the bottom, you can see that it doesn't stop there. Around these initiation point, these seed crystals, when the base asphalt, the binder cools down more, that shrinkage is not as efficient and you get less organized wax crystals, and they touch each other. So that structure would form a gel at low temperature, and you would even crystallize more waxes if you have a poor quality asphalt binder. So that wrecks your road when it is gelled. The thermal stresses in the winter, they don't relax. And then the oils in between those crystals, they squeeze out like a sponge, squeezing out some oils. On the right, in contrast, is an environmental SEM picture. We evaporated the oils. We did that at Queens here. And you can see the resins and the asphaltene molecules, which are the higher molecular weight molecules that form like a brain structure. There's no wax in this binder because it's a good quality crude from Alberta. But what I want to show with this picture is that there is a structure underlying this flat, shiny asphalt binder, and that structure takes time to equilibrate. It takes time to form, and in the winter, it can stiffen the asphalt binder, and it can inhibit the flow at low temperature, and therefore accelerate the cracking. If you use a highly oxidized binder, from an old pavement, you blend it into a new mixture, then this structure will be more pronounced. The volume fraction of asphaltenes will be higher, and you get less stress relaxation. So because it's difficult to do research in the lab, because there's so many different factors that go into road failure, I decided a long time ago to focus my work on looking at pavement trials. In 2001, September 11, 2001, that awful day when the Twin Towers were attacked, I was in Bracebridge, Ontario with Kai Tam from the ministry, Joseph Panaya, and Tony Maslowik. I'd gone there a few months earlier and I said, Kai, we have to look at this. We have 8 to 10-year-old pavements. Some sections look like new and others are rubble. We must be able to do better than this. We must be able to implement and get test methods that actually sort out the good from the not so good binders. So Kai Tam and others following him, Pamela Marks, who's on the call today, fantastic relationship. We were able to design and build another 4 major pavement trials, starting in Timmins in 2003, Castleman 2006, another one in Timmins 2007, and one in the 427 downtown Toronto in 2008. Durham Region, fantastic relationship. Dan Wechter does everything right. We build another trial in 2022. So I will talk to you a little bit about the results today, and they're amazing results. The main message I want you to take away, when we look at the asphalt binder as we extract it from the mix, we can nearly always explain differences in performance, and those differences can be a factor 2 to 3 in benefit cost ratio. A picture gives 1,000 words, and in this case, 2 pictures give 1,000,000 words. I've put on the GPS coordinates. On the left, you can go to Google Street View. You can see it for yourself. The Google Street View images are from a year old. We have this one test section with straight asphalt binder from Alberta. No additives, just some PET fibers as a recycled pop bottles. Whether that's important or not is still an open question, but the straight asphalt binder from Cold Lake, Alberta, will give us a performance lifespan of 38 years to a PCI of 50. Many municipalities can go to 30, 20, and some even go to 10 because they don't have the money to rehab at 50%. So you get 60, 70 years out of your roads, and that's the historical number for how roads would be built prior to Superpave. In the 60s, 70s, and 80s, we had one refinery in Oakville. They used super duper quality crude from Bow River. Petro-Canada, Bow River crude, very good asphalt, no waxes, and RAB wasn't an issue. Not too much recycling going on. On the right, quite contrasting, a Superpave mix with highly modified SBS and some motor oil. You don't mix motor oil, a lubricant, with a highly modified binder because you get a gel, and a gel every day and night, it shrinks and expands and it squeezes out a tiny amount of that lube oil, which gets to the aggregate, and you get this kind of a performance. 14 years, about a third of the regular asphalt without any additives from Alberta. There's 200 years of asphalt binder supply in Alberta to pave every road on the planet, believe it or not, and you can recycle those for 2, 3, 4, 5 times. So we have enough of it. Venezuela has even more. So we work with the ministry, the pavement design and management section, and we use their standard cost benefit analysis software. And we looked at the ARAN data, and we found the Cold Lake straight asphalt performed best. And right next to it, we had the worst performer for a section with 7% polymer. Today, it's marketed to death, highly modified binder. There may be benefits in moderate coastal climates with very heavy traffic, maybe New York City, maybe Miami, maybe in China, in Shanghai. In China, they put in 10, 12% SBS polymer. I would not advise it in Ontario. I would advise against it. This slide also shows if you just put rheop, this motor oil residue, in a regular good asphalt, you lose 40% of the benefit cost ratio. And that's a lot. For municipal budgets, where you squeeze every dollar, this is a massive amount. I'm sad to say, Ontario, we still find motor oil in the asphalt cement supply today. It's banned in the OPS Muni 1101 spec, but agencies don't test, so they still get it today. The test on ash content is not sufficient. So what you get when you put in too much polymer, between 6 and 8%, it phase inverts. The polymer becomes the continuous phase, and the oil squeeze out slowly. This is the sweating and exudation process. Let's go of the aggregate, you get cracking. Highway 417, Trans-Canada, east of Ottawa, the same story, 3% polymer, reasonably good, 0.52. 6%, no better. We get slightly worse performance. But you put 6% polymer in the wrong base asphalt, you get this 82 minus 40 grade, you lose 40% of your performance. That's not good. If then you cannot compact that binder very well, and you get high air voids like the one with the asterisks, you get 0.16 versus 0.52. That's a disaster. You lost 66% or more of your benefit cost ratio. So you have to be careful choosing your binders and do it right. There's companies with beautiful brochures, marketing. I'll leave it to you what to do and what to decide. Don't expect to get the performance that you see in these pictures. So the way I advise municipalities, small users, big users, ban everything you know that is bad. Motor oil, you don't want it. Paraffin oils, very difficult to detect. You don't want those, but we have test methods for them and we're working on it. You want to avoid bad wrap. You don't necessarily want to avoid all wrap. You can recycle responsibly and intelligently. You want to avoid all waxes. Waxes, no good. The literature is full of it, hundreds of references. Still, there are multiple companies trying to market wax in asphalt. A little bit of SBS may be good. Too much, forget it. Pig manure, I leave it to you to decide. You must control the sample chain of custody because samples get mixed up. And you must test the recovered binder. You may also test the tank sample for further information. But if you don't test recovered binder, you're wasting your time. You must use correct properties and you use reasonable acceptance criteria. You neither under-design nor over-design. Getting it right, I put the GPS coordinates on. You can go online, look for it yourself. This is a 10-kilometer contract paved in 2011. This picture is from 2021. I think the Google Street View is 2023. You can go for 10 kilometers west of the Brent Access Road to Algonquin. And you see this kind of performance. It's fabulous. A little bit of polymer in a straight asphalt binder from Alberta, produced in Montreal, used by a paving contractor in Eastern Ontario. Perfect. This is the way every road in Ontario should look like. We get 32 years to a PCI of 65. We get 38 years to 50. And we would get 64 years to a PCI of 30, which would be a good level for a municipality to rehab or reconstruct. So this is the stuff we've worked on for 25 years. I've tried to convince people that you cannot just test after 1 hour conditioning. No, you need to condition for 24 and 72 hours, and then you look at the grade loss from the 1 hour result. This test is extremely sensitive to the formation of gels and the sweating of those oils. But it's been an uphill struggle. These are 5 agencies from Ontario, big users, and then there's 12 from the US. The 6th bar is the average of 95 samples for the US. And you can see agency number 2, that's Durham Region, the smart guy, Dan Wechter will speak to you in a minute. They do not under-design nearly any binders, and they over-design by only 2 or 3 degrees. And that has done wonders for the lifespan of their roads. In the US, the 6th one, nearly everything is under-designed by 6, 7, 8, 10, 12 degrees. And it's mainly wrap, but it's re-op and it's other things as well. Polymers plus wrap, it just gets worse and worse the more you add. This is another picture of the exudation test. 2 on the left, good. 3 on the right, they lose their oils, they sweat out. Getting it right, Princess Street, Ontario, that's Main Street, Kingston. They had the big dig to replace all the sewer system under Princess Street's 8 blocks of paving. The first block has about 40 cracks today. It looks ugly. We get potholes. Spalling has started. We get potholes very soon. That's about 12-year-old picture here. On the right, we told the contractor we're going to test recovered asphalt binder and you're going to meet these criteria or you're going to be penalized. You're not going to get paid. Correct properties, correct acceptance criteria, recovered binder testing, virtually no distress for 7 blocks of Princess. Thank God we did this in 2011 because now a lot of it in Kingston. If we do, and if we stay the course and test recovered binder on enough mix samples, then we can do this. Everything should look like this in every municipality in Ontario. Durham Region, a smart Ontario municipality. Dan Wechter and his staff, all of them extremely supportive. The regional council chair, extremely supportive. All the mayors in Durham, they understand the issue. This is about budgets. In 1980, we got about 30 to 40 years out of pavements. Each point in this graph is the average for about 25 contracts. Around 2013, this is the average of maybe 40 or 50 contracts. There's few from the 80s that are still around, but there are many from the 2013, 2010 range. And in 2013-14, we had a very long, cold winter in southern Ontario, and everywhere we had massive failures. So Dan was smart. He immediately implemented unrecovered binder on all contracts. 2 years later, we more than doubled the lifespan, the projected lifespan of these roads from 2015. It's about 23 years, and we're now back up to 34 years. I know how you get to 40, 42, but again, the industry has to collaborate, cooperate. The ministry has to do its job. Everyone has to come together and say, we cannot continue to throw money at roads that lose 66% of their performance since the 1980s. We have to do it smarter to be more competitive as a province and as a country. To support both the extended BBR and the dent test a little bit more, we looked at individual contracts. We looked at the PCI decay rate. Losses of less than 3 degrees, you get about 35 to 40 years. Losses between 3 and 6 degrees, it gets very bad very quickly. The limit is a grade loss of 6 degrees. Anything over is rejectable, and anything under a CTOD of 14 is rejectable. You can see you can double the lifespan of your road if you do the right test, if you implement it, and if you stick to your guns, if you stay the course. So sustainable recycling can be done. Just replace less of the binder, use the coarse fraction rather than the fine fraction. If you replace a significant amount of the binder, do not expect the same performance from a virgin binder from Alberta, unless you use rejuvenators that actually rejuvenate rather than just soften and exude. They gel, they take time, and they exude those paraffin oils, and you lose your pavement. You must test recovered binders for the appropriate performance-based properties, neither over-design or under-design for the climate. And you should use hot-in-place recycling wherever you can, because that does not suffer from death by 1,000 cuts like central plant regular wrap recycling does. If you cannot do HIR and it is a bad quality wrap, just mill it into the subgrade, do full depth reclamation, and start over with the correct asphalt binder. And then 30, 40 years later, you may be able to do hot in place. So in conclusion, asphalt modification and recycling, it can be a risky business. Bad wrap, REOP has reduced surface lives by 66% since the 1980s. This is not just my data. The ministry has recognized this. We had an Auditor General's report in 2016 that discussed it and talked about it. It's a major problem for Ontario municipalities if you throw away 66% of your paving budget. The extended BBR and the dent, they can provide immediate relief, but you must test recovered binder and use reasonable acceptance criteria. You must also be vigilant for innovative binders such as these 82-40 grades, these highly modified binders. They can pass all the extended BBR, the dent test, but they don't perform well in surface. And Durham has dealt with that issue right away. We should not forget the aggregate, but don't be fooled by the new mixture performance test. Everyone talks about performance test because that's what's being fed to you to make you think that the mix test is all about performance, but many of them miss all of the story I just told you. Hot in place recycling, it does not suffer from 1,000 cuts and death as central plant wrap recycling does. So give it all the attention you can. I am working at the university. If you're ready to implement better specifications, you can call me, you can email me. We are seeking 100 to 200 locations to demonstrate superior Alberta binder. Alberta funds my work because they have $12 trillion worth of crude oil under the ground that can pave every road on Earth for at least 100 to 200 years. Hot in place recycling, we're looking for money from Ottawa, from Alberta, and we can do intelligent things with RAP as well, but not the way it has been done for the last 30, 40 years. So these are the acknowledgement and a disclosure. I'll hand over the screen to Dan. Please put your questions in the Q&A. I can answer some of them. And when Dan is finished, we can answer and discuss a few other questions. I thank you for listening, and I wish you all a good day. Bye for now.
Good afternoon, everyone, and thank you, Don and Simon, for your kind introduction. I'd also like to thank the Ontario Public Works Association for giving us the opportunity to present today. As stated, I'm Dan Wechter, Acting Director of Transportation and Field Services and Construction Manager for the Region of Durham. I'm following up on Simon's presentation showing how the region has put into practice some of Simon's research and expertise in our construction of Regional Road 18 pilot road rehabilitation project using recycled materials. This project, as stated, was created out of Council's desire to invest in a circular economy, constructed a works department to explore options for incorporating recycled materials in road construction, investigate the viability of creating a resource from recycled materials generated and collected through our own recycling program. Glass, plastic, paper waste is collected and sorted at our material recovery facility. Glass shown here is separated and stockpiled. It also contains pieces of plastic labels and lids, metal lids, pieces of porcelain and ceramic, not all ideal for use as an aggregate. These recycled plastics are sorted, separated, and baled at a MRF as well. And these are the materials that we investigated for incorporating into road reconstruction. Candidate road segment was selected after analysis of our regional inventory. We chose a rural 4-kilometer road segment on Regional Road 18 between Kendall and Concession Road 5 in the municipality of Clarington. The segment had a low annual average daily traffic, which pavement condition index of 4. So it was obviously in desperate need of rehabilitation. Split this segment into 2 phases, each 2 kilometers in length. Phase 1 utilized our conventional road rehabilitation and recycling techniques. Our traditional rehab recycling methodology includes culvert replacements, ditch realignment and regrading, pulverizing the existing road surface and granulars, which are usually contaminated, placing fresh granular and 2 lifts of new asphalt. So this process, we are recycling and reusing the existing road surface and granulars, reusing all millings on site, as well as reusing all excavated material from the culvert replacements and incorporating it into the ditch work. So very little, if any, material leaves the site. So then phase 2, we used the similar techniques while also incorporating recycled glass and plastics. Now we intentionally plan to construct phase 1 and 2 right beside each other to ensure they share the same road base and were exposed to the same traffic and weather conditions. This provided an ideal condition to compare and monitor the performance of the plastic modified asphalt directly against our conventional asphalt. Here's the existing road profile prior to construction. You can see there's several significant modes of failure evident: transverse and longitudinal cracking, alligator cracking, and rutting. Even the previous repairs were failing. So you can see this profile was in desperate need of rehabilitation. During the design process, we partnered with the region's only glass processor, Nexcycle. Time limitations on finding a local industrial partner to process our own glass made us turn to Nexcycle. They receive recycled glass from Durham Region and other Ontario municipalities. They processed and sorted our glass to 2.5% non-glass material. It's very difficult to remove all of it. It was ground to approximate 6 millimeter size, which was ideal for our application. We took this sample and we blended it with some of our typical granular A and B, tested it at our materials testing lab, and it met the requirements of OPS 1010 and found it provided a competent aggregate. We also partnered with Revita Polymers, who process our mixed plastic, and they provided mixed plastic pellets for addition into our asphalt mixes. It contained high density, low density polyethylene, polypropylene, and polystyrene. Now, extensive laboratory testing throughout 2021 by Professor Hesp determined that the optimum plastic concentration in asphalt is 0.3% by weight. Simon, I recall, I think you tested approximately 100 local asphalt samples with varied amounts of plastic in it to come to this conclusion. Close-up view of the mixed plastic pellets show very clean material, pea-size, round and smooth pellets that can be added and mixed easily through asphalt batching process. And the pellets will melt into the hot asphalt. Another key component are PET fibers. It's polyethylene terephthalate. Fibers in there constructed from recycled plastic bottles. They have a high melting point, so they stay solid in the hot asphalt and provides fiber reinforcement against tensile strain to prevent cracking. We used approximately, I think, 3/4 inch, 19 millimeter size. Simon's testing also revealed optimum concentration was 0.3% by weight. This is approximately 30 times the amount of virgin fibers currently used in the industry. And this is, Simon helped us out with this data from pavement trials, recycled fibers on Ontario highways 427, 655. I'm sure there are others. The region and the city of Oshawa have used Kevlar virgin fibers on recent road projects at 0.1%. But this is the first time the region has used fibers made from recycled plastics. Here's our typical design road cross-section. The recycled glass was placed only on the east half to compare and monitor the differences in performance. Road segment was divided into 5 test sections. So the mixed plastic was varied in each test section. It was placed in the base asphalt. The PET fibers were placed in both the base and the surface asphalt. So the first section, we just had straight asphalt. The next had PET fibers in both the base and the surface. Next section had mixed plastic in the base, fiber in the surface, and the last 2 sections had mixed plastic just in the base, one at 0.3% and the last one at 0.6, so double the amount. So we can test and monitor the performance of all these different combinations. With the tender design complete, the project advanced to construction. Here we're acknowledging the federal funding that made this project possible. Once the culverts were all replaced, moved on to placement of the recycled glass. Now in the past, when the region utilized recycled glass many years ago, we blended the glass with granular B offsite, and placed and compacted this blended material in our road excavations for our road reconstruction projects. We couldn't do that here, so we needed an innovative way to incorporate the glass. So our plan was to place the glass with live bottom trailers on the existing road surface and pulverize it with the existing road and base. So the road was pulverized in 200-meter sections, did the west side first, then the east, and that allowed us to maintain traffic. So as the glass was placed, it laid down exactly where it was dumped due to the angularity of the glass. The windrow of the pulverized southbound lane kept the recycled glass in excellent position, with no glass leaving the road surface. That was a high priority for us. You can see also water application on the road that aided in compaction. Glass was graded immediately after placement to a 25-millimeter lift. Once again, you can see no glass leaving the road surface. Multiple passes with the pulverizer used to grind and blend the existing asphalt, granular, and recycled glass. Pulverizing to the edge of the existing platform produced a clean edge line, also high priority for us. Close-up revealed a well-blended mix of glass, existing asphalt, granular. The blended material resembled a well-graded granular A and B mix. So we're again very pleased with how this turned out. After the first pass, you can see the pulverized glass material, and the particles were very well dispersed and barely visible at a distance. Here's the recycled glass placement process train, the pulverizer, smooth drum roller, and grader, compacting, fine grading pulverized material. Blended material compacted very well and was able to support traffic immediately. No deformation or rolling was observed. Here's the entire pulverized road platform, east half with recycled glass and west half without. You couldn't tell the difference between the two, both looked very similar. So this pulverized platform provided excellent strength and was able to support traffic without any additional granular material added. So we're very pleased with this result, and it certainly helped keep the operation moving very swiftly, efficiently. Here's a full pulverized platform with improved ditches prior to the placing of asphalt. Exposure to traffic provided additional compaction and consolidation of the granular base. Now, full disclosure, we had a few complaints from residents after pulverization concerning the appearance of the non-glass material, the colored glass, during placement, and also had a slight odor from typical residue in the glass jars. Any odor disappeared as the glass was pulverized. However, to be thorough and put the residents at ease, we conducted an environmental investigation. So we paused paving, advanced test pits every 50 meters in the northbound lane where the glass was placed, and we took the test pits near the shoulder in the center and middle of the lane. A typical test pit exposed a homogeneous road-based mixture, granular materials, and crushed glass. A few small pieces of colored porcelain and ceramic plastic are evident if you look closely enough. A total of 40 test pits were advanced. Samples were tested and analyzed using a T-clip toxicity characteristic leaching procedure. The results were so low, they were below the detection limits of lab equipment. So the material was demonstrated to be non-toxic. So then paving operation commenced after these positive test results. So this process has motivated us to process our own glass for our 2024 projects to a cleaner standard and reap more economic benefit. To that end, we have sourced a mobile screening unit that uses mechanical screening conveyors modified with magnetic separation of ferrous materials, followed by air scouring non-glass materials. We will be in control of all quality control and quality assurance and testing to ensure our recycled glass is as clean as possible. It's a shot of QP's Oshawa asphalt plant. It was used to feed aggregates AC, mixed plastics, and PET fibers into the batch plant for production of the different asphalt mixes used. And Krupe provided all the asphalt used on site. Mixed plastics and PET fibers had to be measured into 6 kilogram bags to facilitate precise addition into the asphalt batches. In order to achieve 0.3% concentration by weight, 1 6 kilogram bag was required for every 2 tons of asphalt. Here's a mixed bag of plastics shown on the left. PET fiber bag is larger as fiber is less dense than plastic pellets. The mixed plastic and PET fiber were added manually at the top of the plant. We had to increase dry mixing time with aggregates and manually open the bags first to ensure thorough mixing. So some experimentation was required on trial batches. Here's a paving operation. The asphalt process train, the paver, spreader, material transfer vehicle, and trailer supplying the asphalt. The shot they're paving the mixed plastic asphalt, and the mat looked very good. Again, we're very pleased. Here they're paving the PET fiber mix while maintaining traffic. The operation moved along very, very efficiently. You can visibly see the high concentration of the PET fiber shown thoroughly mixed in the hot mix asphalt. Those strands hanging down from the shovel, those are the PET fibers that we hope will give us the tensile strength and the resistance to cracking that we're looking for. Here's a shot of some core sampling we do on all road projects. This was no exception. It's used to test asphalt properties such as compaction and thickness. And this in addition to, most important, our extraction testing that Simon was talking about, test the material placed on site. It's very important. It's a key component of our quality assurance process, and we feel is largely responsible for improving quality of our asphalt over the last decade. And we had to use various combinations of rollers to compact the plastic modified asphalt. These mixes compact more quickly and had to be rolled at cooler temperatures. So some experimentation was required to optimize the timing, combination of rollers to get the mat that we were looking for. Here's a shot of the fully paved platform with modified ditches, new guide rail, and line painting. So you can see it's an incredible improvement over what was existing. Very impressive platform, and our residents are very pleased. Another shot of the finished product, and we expect this road segment life cycle to significantly exceed our standard 20 years. And our goal is to get closer to 40 years, as Simon explained in time. Benefits of all of our efforts here, Simon discussed and showed this slide as well, with our enhanced specifications, extraction tested of the asphalt placed on site, QA testing protocols. We've seen significant improvement in our road life cycles over these past 10 years. So many thanks to Simon for all of his assistance. And so it's what we're doing is paying off, and it's translating into huge cost savings and environmental benefits, as you can appreciate. As always, it's great to receive some positive acknowledgement. So again, many thanks to the Ontario Public Works Association for presenting us with this award last year. So that concludes our presentations. Maybe Simon, if you want to put up your contact information, and I guess we can address any questions that our audience may have.
All right, thank you very much, Dan and Simon. That was a great presentation, and yeah, a wonderful project. I mean, just working smarter, reducing costs with tight budgets these days, and that's the environmental benefits. Just a real positive work, you know, going from research and academic work and criteria to actual implementation. So there have been a number of questions through our Q&A box, and Simon has been at least on his part of the presentation, was able to answer a number of them. Is there some, I'm just going to toggle down and see if there's any new ones that were not answered, or Simon, were you able to get to most of these?
There is one I can address from Sam Poole. And he asked if there are any specifications, examples of sourcing Alberta binder in the tender documents. So for the trial, we actually sole sourced, and we said it must be Alberta binder. We asked them to show us the waybills and proof of payment. And this was a supplier in Ontario from Hamilton. They already use Alberta binder. The key was the testing of the extracted and recovered binder to make sure we get the properties that we know should be possible with a straight Alberta binder. It is also made in Montreal. The refinery from Suncor runs at 100% Alberta crude. So the key is to ask for what you need, which is the new specifications, so that between the refinery and what you extract and recover from your mix, nothing negative happens. It could be wrap, it could be overheating, it could be addition of waxes, too much polymer, who knows, overheating in silo storage overnight. It can wreck a very good asphalt. So you have to be very careful that you test the product as it is laid in the contract. That's what you're paying for. So don't just test this tank sample because you're wasting your time. You should test the tank sample from time to time to get information and to know what changes between the tank and your recovered binder. There is a big change, then there's issues there as well. But it's easy to specify in your contract. You should not specify Alberta binder, but the reality is that most of the binder sold in Ontario comes out of Alberta. There's some that comes from the Chicago area, and they use crudes that are produced through fracking, and they have higher wax content. So cheaper crudes in the Chicago refineries, there's two very big refineries in the Chicago area. They could make it up to Ontario by barge, and that's the stuff you probably don't want. But to specify that is impossible. So you need to test for the performance-based properties, and those are easily put in any contract.
Okay, thank you, Simon. There's a question for Dan here. So Dan, what specific laboratory tests were conducted to determine the optimal concentration of PET fiber in asphalt, and how do these results compare to previous studies on virgin fiber reinforcement?
I think that's more in Simon's area of expertise. He did the laboratory testing for us, and that was in our pre-design and design stage. Why don't you elaborate, Simon?
Yeah, so PET fiber has been used by other people before we even did any testing in my lab. It has been used in the Federal Highway Administration in McLean, Virginia, just outside of Washington, D.C., where one of my postdocs has been working for 25 years. One of my PhD students is working there. So 25 years ago, they did studies on an accelerated load facility where they have a heavy vehicle simulator that goes on strips of asphalt for days on end. And the best performing mix had some PET fiber in it. And I said, we must try that in the real world. So we got the test section in Timmins. We got one in a contract on the 417 near Ottawa. And we got 4 test sections on the 427, which is on top of a Portland cement concrete pavement. And even there, it increased the lifespan significantly. And PET fiber is a ductile fiber. It's not a brittle fiber like glass or a metal fiber. It's ductile at low temperature. It pulls. So it has extraordinary toughening properties. But having said that, with all the research we've done in my lab, I'm still not convinced that it makes a huge difference. It could well be only the base asphalt from Alberta that makes the biggest difference. So we have to do more of this, and we have to learn more about it. And you have to force the contractors to do more of this as well, intelligently, without messing it up by putting in another truckload of wrap. So that's the answer to that question. Other people have done it. 0.3% on the mix. It's about 3 kilograms per ton of mix. And it adds a few dollars to the hot mix price, almost insignificant.
Okay, thank you, Simon. Quick question, will the video be available after the session? Yes, I can answer that question. It will be posted on the OPWA website. Give us a little bit of time to get that arranged. We're working with a new website platform, so hopefully that will be done shortly. Question here. I understand the road surface recycling is working on equipment to remove metal and plastics.
I can field that, Don. That's okay. Yeah, we are working with them for their hot in-place recycling. We've got a couple of road segments this year. We're gonna give it a try. I think this refers to separation of metal and plastics from the recycled glass, and the answer is correct. We actually partnered with Power Screen, who in Oshawa, who are providing that mobile unit, conveyors, and I think RSR are supplying the magnet, help remove the metal, and the blower attachment with the air scour to help remove more plastic. So we've had a few test runs. Seems to be working pretty well. We're stockpiling our recycled glass. I think around in May, we're going to deliver the unit over to our MRF for about a week and run everything through it that we've got. We're going to use our loader to drive over the glass and grind it up to the size that we want, and make sure it's as clean as we can get it. And the MECP has been invited to come over and watch our operation as well.
Okay. Question is, was there concern about breathing in fine glass particles?
Yeah, I think the short answer to that, Don, was no. Wasn't a lot of dust, and no, there wasn't concern. That process moved very, very quickly. The one concern we had was some odor on site, and that dissipated as soon as we pulverized the glass.
Okay, well, these questions are jumping around here. Can you speak at all to the reduction of greenhouse gases using recycling techniques?
Sure. I mean, Simon, I'm sure you could elaborate at length, but any of the recycling that we do obviously is a benefit. As we said, our traditional road rehabilitation techniques is designed to leave all the existing road materials in our right of way, right? So it's considered an asset. So we're trying to leave it there and rehab it, recycle it. That's another big plus for hot in place recycling, and then reusing our glass. It's an aggregate, so we don't have to truck in other virgin aggregate. So all that's ideally saving trucking and extending the pavement life, say doubling it. That's a lot of construction effort that you're saving, as well as budget and funds, as Simon noted. Not sure if you can add some more, Simon, to that.
Well, I think the benefit cost analysis that was done by Stephen Lee's group at MTO, Pavement Management and Design, they do this stuff all the time. They look at just dollars, money in and money out. And we found factors of 2 to 3 differences in benefit cost ratios, depending on the type of binders that we used. In Durham, we went up from 11 years in 2013 to 24 in 2016, and we're at 34 now. So we're reducing their expenditures by 60, 70, 80%. But aside from that, on top of that is the reduction in greenhouse gas emissions and the reduction in user delay cost, which in busy areas is probably several-fold the economic expenses in terms of materials cost. So it's immense, but I read quite a bit of that literature, and nobody really has a good handle on greenhouse gas emissions and user delay costs and all those kind of things. There's too many assumptions made. But as Ted Phillips, who is on this call, I believe, used to say, it's a no-brainer, Simon. It's a no-brainer. A lot of this is a no-brainer. I very much hope that before I die, everyone else agrees with me, and that we see it everywhere in Ontario and in North America, that we do a little bit more intelligently when we select materials. This is money that is leaving our province. There was a report from the Bank of Canada yesterday that for every dollar earned in the US in 1980, Canadians would earn 88 cents. Today, for every dollar earned in the US, Canadians earn 71 cents. So we're losing our competitive edge. So by throwing money at the roads that last only 30% of what they did in the 80s, this only hastens our demise. So this is what has kept me going, is to do better for our children, that we leave the place a little bit better than what we got it. And as I said, most of the money is now multinationals. It goes to foreign countries. Be wise, don't be stupid, do it just right. Dan Wechter here has done it. Everyone else can do the same thing. The contract north of Algonquin, it's going to last 40 years. Why not everywhere? 10 kilometers.
That's excellent, Simon. What a great, I think, way to end this presentation today with some very wise words and thinking about the future and sustainability, etc. So thank you very much. Thank you to everyone that's attended this webinar today. We stay connected with OPWA through the various means that I talked about earlier. And once again, thank you so much, Simon and Dan, and to Durham Region for this great webinar. So to everyone, have a great afternoon. Thank you very much.
Bye for now.
Thank you, Don. Thank you, Simon.